So for this problem, we are going to do a one-story medical building with a basement for storage. So here is the steel frame right here. You can see that there are 12 columns. We have 1, 2, 3, 4, 5, 6, 7, 8 girders, and 1, 2, 3, 4, 5, 6, 7, 14, 21 beams overall. And now we're going to design each of them. So there are four members that we are expected to design: an interior beam, an exterior beam, an interior girder, and an exterior girder. In this class, we will not design columns. So columns is something that if you pursue civil engineering, you'll do in college. We are only expected for beams and girders. In order to do a beam and a girder, we need to know the loading on top of it. So the dead loading is often assumed in the real world because it's kind of standard. Like you have a standard beam, you have a standard flooring. Like it's somewhat predictable. Like you can kind of predict it. Typically, it's like 30 to 60 depending on what it is. So and for this class, I'll tell you what the dead load is. The live load, you're going to be expected to figure out from the website. So the live load, we're going to go to this website over here, this patriotic website. And I think I said it was page 43. And you have to look for, like I said, it's a medical use, right? A medical building. So you're going to have to look for like the most relevant. So I'm looking, and if you see it, shout it out. I'm looking for like anything. It's like doctor's office, medical. I see hospital. Office building? It's kind of like an office building. I guess it's most like a hospital. So I'm going to do the hospital live load. We'll do this one. We'll do 60. And what's the units for that? It's uniform pounds per square feet. So back to here.
Coop, if you give us like a question on a test, it's gonna match up like perfectly, right? So
I would do one that was a lot more obvious. So I would use wording that like, hey, what's an operating room for a hospital, or what's a stack room of a library? It would be a lot. It wouldn't be as vague as the example I just did. So where are we here? So the live load we know is, I'll just kind of write this over here. What did I say? 60 PSF? Yeah. Okay, so now we're going to do the interior beam first. So an interior beam is just not these 6 on the outside. These are all interior beams. So I'm going to go over here, and the next question is which type of loading is an interior beam? Distributed. I agree. I like can't get to the bottom. All right, I gotta fix my toolbar. How do I do that? I do have that on. This is a weird problem I have. I like can't get to the bottom. There we go. Okay. So the beam length is how much?
25.
25. The tributary width is, I think, where a lot of people are getting thrown off. Tributary width is the width that the beam is responsible for holding. And this is what varies between interior and exterior beams. So an interior beam is going to be responsible for halfway to the nearest beams. So this beam right here, where my cursor is responsible for halfway to this beam, all the way through halfway to this beam. And that width is going to be how many feet? 10, because it's 5 in one direction, 5 in the other. An exterior beam only has to go to halfway to this interior beam. There's nothing on the other side of it. So an exterior beam would only have a tributary width of 5, and that's where it differs. So for this one, it's a 10, and then in this case, we are being measured in pounds per square feet. Had I told you that the load is pounds per linear feet, what you would do is you would just have the tributary width be 1, because tributary, or the pounds per linear foot, is just going to be the pounds per square foot multiplied by the tributary width. So for that homework problem last week, the tributary width would actually be 1 because I gave it to you in pounds per linear foot. And pounds per linear foot, again, is just pounds per square feet times the tributary width. So the dead load was 30, I believe. And then the live load was 60. Boom. All right. F of y is 36 KSI. I think this does it in PSI. So just make sure you're watching units. 29, 1, 2, 3, 4, 5, 6. And this part you guys should be like decent at, right? I mean, we got to go to that website now. So I do want to do the full process for one, and then for the other ones, I'm just going to talk through, because a lot of you guys are choosing not the lightest member. So I want to do one together where we are choosing the lightest member. Then the rest, I think I'll just kind of let you guys. So where was it? Okay. So here. So now we're going to pick the lightest member that has at least 39.14. So you got to go to properties. And I believe what some of you are doing is you're picking like a W14 or W12 or W16, and then just picking the lightest one of those, not looking at the next highest or next deepest member. So what was that number again? 39.14. So we're going to go all the way down. And, we'll start W12, although I imagine it would be a little higher than that. So the lightest W12 is, I have terrible memory, 39.14. So the lightest W12 would be which one?
W1230?
Yes, W1230 would be the lightest W12 member. Now, once we have the lightest W12 member, we're going to look at the next deepest member and see if the lightest one of that is heavier or lighter than this one. And we're going to keep doing that until it doesn't work anymore. Typically, like a rule of thumb-ish is how do I want to word it? Basically, like typically the member that works is the one that's closest to the lightest member for that entire W series. So if you're picking like W12 by like 252, there's guaranteed to be one that's lighter. You want to get as close to the bottom of the W series as you can. Does that make sense? Like you want to be kind of closer to the lightest member that exists for it. If not, you can probably get the next tallest one. So we want to look at W14s to see if there's anything lighter than a W12 by 30. And is there one that exists? Yes, W14 by 26 is more than 39, and it's lighter. It's 4 pounds lighter, which means it's less material. So now W14 by 26 is the next one. We'll look at W16. Are there any lighter W16s? Well, I see W16 by 26, which weighs the same as the W14 by 26. So which one would you choose? A W16 by 26 or a W14 by 26? Well, you would look at which one's stronger, right? If they weigh the same, I'm going to pick the one that is stronger. So a W16 by 26 has a strength of 44.2. The 14 by 26 is 40. So I'm going to choose a W14 by 26. We can look at the next one. I imagine that one, or sorry, 16 by 26. I imagine that would be the lightest one because this is already the lightest of the W16. So the W18 is not going to have one that's lighter than that. Probably. Yeah, 18 by 35. All right, so we're choosing W16 by 26. So 44.2. And while I'm here, I'll do the inertia, which is 301. What was the number? I have really bad short-term memory. 44.2. And then the I believe, was 301. And then we're going to go to dimension and go down to 16 by 26 and 0.25 and 1569. Boom. And good. This member works. Okay, so now we've done the interior beam. Are there any questions at this time? Okay, I'll take that as no questions. So then you would screenshot that and then pop it in there. And then for exterior beam, what's the only thing that's changing when we're doing exterior, when we start this problem? We said it before.
Tributary width.
Tributary width. You're just going to change that to, I believe it was 5. And then you see how that dropped? It's going to, you just have to now just do the process again with a different Z. So I'm not going to do that now because I don't think it's, I think you guys should be able to figure that out. Okay, so now we're good with interior beams. Now we're going to look at girders. So an interior girder is going to be one of these 4 right here. The exterior girders will be these 4 over here. So let's do an interior. We'll do an exterior first. They're slightly easier. So we say that beams that tie into columns bypass the girders. Hang on, let me just double check my video, see how we are with time.